in this talk. A specific question when developing dialogue systems, we always are faced with the difficult question of understanding, and how can we implement this the natural language understanding module. And I will focus in this talk on the question of the common ground. The common ground is when two people are interacting there, the purpose of the interaction is to build a kind of shared knowledge. So the common ground is the other name of this shared knowledge between the two persons that are interacting. So okay, right. I will. Okay, what's the context of this specific dialogue system? We are developing. We are faced with. We were asked by hospital doctors to try to answer to develop a new system, helping the doctors to train them to break bad news. So this is a situation doctors are very often faced with, and they are not really trained for that. And this is very difficult and important question for them, being trained to break bad news. So at the moment, this kind of training is only organized by workshops during which doctors discuss this bad news to actors. Okay, and this is the picture in this slide, and you can see a student training for this type of task. So this is very difficult to do, and what we are developing is a platform, and more specifically an embedded conversational agent in virtual reality systems, a platform making it possible to have doctors interacting with virtual patients. And this is in this picture you can see our system in the cave, and in which we have the user interacting with the virtual patient. Okay, so this is the general context. In this type of system, we are in the specific situation of a task-oriented dialogue, which is a specific type of dialogue system. And what is very specific to our task is that we are in the context of what we call a closed world assumption. The closed world means that we have the complete knowledge of the universe of discourse. Okay? The semantic, the understanding and interpretation of what the doctor says can be restricted to a very specific context, because we know everything about the task, and we know everything about the context in general. The task is fully described, and what happens in the dialogue is that the different participants, well, in this case the doctor, instantiates step by step the information to be disclosed. So in this type of dialogue systems, the questions are always the same. First, how can we represent the meaning? How do we implement the instantiation of the meaning during the conversation? And how, thanks to this knowledge, how can we control the conversational agent's behavior during the interaction? So in the rest of this presentation, I will focus on three different sub-questions. One is, well, what is a definition of the common ground, and how is it possible to represent the meaning in this type of situation with this common ground ID, the shared knowledge between participants. Second, how to instantiate this common ground during the interaction, and finally, how to use this common ground in order to control the system during the interaction. The theoretical context of the meaning and representation and the semantics in general we use in this type of system is based on what we call frame semantics. Frame semantics is a linguistic theory in semantics that has been developed years ago, decades ago by Fillmore and colleagues, and which is based on the idea that we can describe the knowledge thanks to different frames, each frame representing a type of information, the support of the information, and each frame being described by different features, different characteristics, making it possible to have a very sparse representation of the information. And the idea is to base our common ground knowledge representation on this notion of frames. So in general, knowledge is based on two different types of information. One are entities, the objects that we can refer to, and the other units are events. Okay, and events and entities can be described in terms of such structures or frames. And for example, here I give the example of the description of the event of a surgery, in which we can have two different features describing that are typical to this event. One is the pathology, and here are examples of pathology, and the second is the type of surgery. Okay, and what's interesting in the type of dialogue systems we are working on, and in particular, more specifically, what's interesting when using this closed word assumption, is that most of the features can be a default value. Okay, so for example, in this, if we take again the example of the frame of the surgery, we have a default value for the pathology, which is polyp. Well, this is an example, only an example. And with this type of pathology, we have a default value for surgery, which is celebroscopy. Okay, so now the organization of the knowledge is again very specific in dialogue systems in general, in task-oriented dialogue system in particular. The initial background between the system and the user, in our case between the doctor and the patient, is the same. In other words, both users share the same initial knowledge, and they know, and including the system itself, know everything about the context, the pathology, the degree of severity, the risk, and so on and so forth. The same with the user, the doctor, and this means that we are in a very specific situation during the interaction, building the common ground, building the shared knowledge consists in instantiating step by step the knowledge, and sharing step by step the knowledge that is already known by both of the users. So this is what I mentioned here. The doctor instantiates incrementally pieces of knowledge, at each step of this incremental instantiation, new information can be inferred. This means that thanks to the general representation of the context, any new information which is given, which is instantiated during the dialogue, can at the same time infer new information. So, so this is the general types of information that can be used for building the knowledge and understanding what the doctor is saying. And in particular, I focus here, and I will focus on the rest of the presentation only on the common ground, which is the specific shared knowledge between the two participants. We also need to have the complete understanding, the belief based, which makes it possible to infer new information, and the common ground is what has been said specifically during the interaction. Here is the representation of an extract of the common ground, and we can see that in this example, which is based on the representation of a typical interaction between the doctor and the patient, we have the initial state And this is the first frame we are instantiating during the dialogue. We have the initial state and the features, the different features, the different elements of this frame are given there. And we have the patient, which is a person. We have the pathology, which can be described with some other specific description, the location of the cause of the interaction, the gravity, and so on and so forth. So this is the frame, and the common ground is a set of frames that can be connected to each other thanks to this specific relation. For example, the patient is described by another frame which describes the person. This is a subframe: person, name, sex, etc., condition. The pathology is described by also different features: type, location, remediation, gravity, and so on and so forth. Okay, so just keep in mind the fact that what we are doing during this interaction and the natural language understanding module consists mainly in instantiating this common ground, okay, these different frames and the different features. So more technically and more specifically, this consists in first identifying the frames to be instantiated, and then instantiate the different values of this frame. So for doing that, we have developed a classifier, the idea is to make a relationship between what we call dialogue acts and frames. I will give some example in the next slide. So the first step of this of the understanding for us is to identify the dialogue acts or the frames, and then to instantiate the different slots, the different features of this frame. Okay, so the common ground is exactly instantiating, building the common ground, instantiating the common ground is exactly these two operations. So how to identify the frames? What we did, but this is specific to our dialogue, but this can be generalized to other type of dialogues. What we did first is to identify the different frames, making it possible to represent the complete knowledge of the system. So classically, we have opening and closing frames. These are typical dialogue acts. We have questions. We also have feedbacks or back channels. These are the typical dialogue acts, but we have more specific dialogue acts for describing that are specific to the interaction between the doctor and the patient, which describe first the state of the patient before the interaction. What is the remediation which is required for this interaction? What is the bad news? How can we fix the bad news? And what are the expected benefits or the expected consequences of this remediation? And we have here the different dialogue acts which correspond to the different frames, which corresponds in the end to the complete common ground. And identifying first these frames and instantiating the different features makes it possible to have a very precise representation of the knowledge. Okay, this can be done thanks to the classifier we have developed. I give here, but I won't enter into details, but I give here the main features we use for our model. And just to mention the fact that we have a very rich set of features first, and we have on top of the classical features that are used for developing dialogue act classifiers, which are based on n-grams, word n-grams, and n-grams of characters, and so on and so forth. We also introduced higher level information and higher level features, for example, the number of modifiers, number of clauses on top of that. And we also introduced some specific information concerning the discourse level, for example, the fact that we use specific or technical terms, or the fact that we use that we introduce new reference and so on and so forth. So this is the complete set of features we use in our model, and I just give you a few results about the evaluation of the classifier. This is a hierarchical classifier in 2 levels. The first level, in the first step, we identify the main classes or the main frames with as you can see, a very good efficiency. And then this is the accuracy there. And the second step is the instantiation of the different specific classes, the different specific frames that are specific to the context of the interaction between the doctor and the patient. So this metaclass level is generated to all types of dialogue systems, and we reach again the state of the art thanks to this classifier. And at the second step, we have developed we have trained a specific classifier for the fine-grained level specific to the context of this application. In this case, with a rather good result, we have 0.77 we're using random forest there. As I explained before, when we have identified the frames, then the only thing to do is to instantiate the different slots. And instantiating the different slots is straightforward because we can identify, because we know the frame, we know the features of the frames. For each features, we know the type of the features and what is expected as value for this type of for these features. So mainly only by identifying the entities in the utterance of the doctor, which has been produced by the doctor, we can straightforwardly instantiate the features and then the frames. Okay, so we can in the end have this common ground, and we can do many different things with this knowledge of representation and with this the information which is represented in the common ground. First, what we can do is to answer a question, and to answer directly question with a very precise identification of the question, a very precise analysis of the question. And for example, what we propose here is to describe question, the different types of question. Each type of question can be connected with a specific form, a specific morphosyntactic form, and we have very specific expected answers that can be connected, that can be identified directly and again straightforwardly with the question. So in other words, when we identify the question, and we also have developed a specific classifier for the different types of question with a very good accuracy there. So we can identify straightforwardly the questions and interestingly straightforwardly the answer to be given to the question, because we know, thanks to the classifier, what is the question type and what is the expected answer. And the expected answer, we simply need to identify the features within the common ground corresponding to this expected answer in order to build the answer of the question. Second application of the common ground in this dialogue system, turn-taking, and more particularly generating clarification question. As you probably know, this is a very important task for dialogue systems. The most important one is to understand and to instantiate the common ground and to do things, but clarification questions are very important. And in this case, this is again generated straightforwardly just by looking at the state of the common ground. And we have different situations when looking at this the state of the common ground. One is when we have a mismatch in a temporal mismatch in the order of the instantiation. So this is represented in the knowledge base of the system, we know that we need to instantiate first. I give here the example. We need to instantiate it first, the frame symptoms, all the information associated with the symptom. We need to speak about symptom before speaking about the diagnosis. Okay, so if we during the dialogue, if the doctor give a diagnosis without having identified or speaking with the patient of the symptoms, then there is a mismatch. And in this case, we know that because of this temporal mismatch, we know that we have to generate a clarification question by the system. Second, more specifically related with the understanding itself, the second type of mismatch is when there is a mismatch between what is expected for the features and what has been realized by the doctor. In other words, I mentioned the fact that we have default value, and when there is a mismatch of the type of the default value of what is expected by the system and what is generated, what is produced by the patient. This is again identified very straightforwardly when we try to instantiate the common ground. If the default value or the expected value does not fit or does not unify with what is realized, then there is a clarification question. And in the end, at the end of the interaction, it's also very we can also identify very easily whether all the important information have been given by the doctor, or whether all the mandatory values are instantiated or not. And in the case where the doctor does not instantiate, does not give all the required information, then there is this is the third case of the generation of a clarification question. And finally, the feedbacks also, you know that especially when interacting with in virtual reality with an embodied conversational agent, the agent has to produce feedbacks very regularly. Feedbacks are this type of short events that make it possible for the interlocutor to give a feedback to what the main speaker is saying. And in this case, it's important for the agent to have notes or short assessment like, yes, okay, this type of thing. So this is very important. And we can produce feedbacks also thanks to the analysis of the state of the common ground. And for example, when we instantiate the frame bad news, then we generate immediately a specific back channel or feedback, which produce a surprise and a specific emotion for the agent. The same with when the doctor is producing a social interaction, then we generate a specific feedbacks for that. So this is answering question, generating clarification question, generating feedbacks are third examples of what we can do with the common ground. So in conclusion, what we again because of the specific application, and because of the fact that we are in a task-oriented dialogue, and in a very specific task-oriented dialogues, what we did for developing this system is to have a very high-level and symbolic representation of what the interaction is, and a very specific representation of the knowledge, which makes it possible to have specific mechanisms for the natural language understanding module, which is based on this common ground instantiation. The common ground instantiation makes it possible to represent all the events that can be activated by the different cues, makes it possible to specify default values which makes the dialogue and which makes the generation of the reaction of the answers of the patient very easy to calculate. And we can identify we can weight the importance of the information which has to be given by the doctor. This makes it again easier to control the dialogue. This common ground offer the possibility to directly control all the different sequences of the interaction. In particular, because of this question of saturation, because of the possibility to identify whether or not all the information that has been given for filling a specific phase, then we have very precise control mechanisms for developing, for implementing the control of the dialogue system. Finally, what we still have to do is to propose an evaluation of the quality of the interaction, which has been produced by the doctor, and to generalize this type of architecture to other type of dialogues. Thank you for attention, and sorry again for the problem I encountered at the beginning of the presentation.